Hello friends, myself Renuka Vinayakrao Siraskar. Today I am going to represent a seminar on the topic coulometry. So let's start it. Coulometry. I will explain it in the terms of introduction, principle, types of coulometry, instrumentation and application. Introduction of the topic coulometry. Coulometry method of analysis based on the measurement of quantity of electricity that pass through a solution of an electrochemical reaction. The coulometry method is mainly based on the measurement of quantity of electricity. The sample which is to be determined undergoes the reaction at electrode which is measured at the electrode. Principle of coulometry. The main principle involved in the coulometry is measurement of quantity of the electricity which is directly proportional to the chemical reaction at the electrode. This is given by Faraday's law. Faraday's law is Q is equal to NF/Na, where N is the number of electrons per mole of analyte. F is Faraday's constant. The value of F is 96,487 coulomb mole inverse. Na is the moles of analyte. Types of coulometry: potentiostatic coulometry and coulometric titration. So I am going to explain coulometric titration. Coulometric titrations use a constant current system to accurately quantify the concentration of a species. In this experiment, the applied current is equivalent to the titrant. Current is applied to the unknown solution until all of the unknown species is either oxidized or reduced to a new state, at which point the potential of the working electrode shifts dramatically. The endpoint of the titration can be analytically calculated by using an indicator that is placed in the sample and signals when the system reaches equilibrium. Alternatively, the endpoint can be determined from data provided by potentiometric, amperometric or conductance measurement. The analysis time is shorter because the current does not decrease over time. A typical analysis time for control current coulometry is less than 10 minutes. Silver coulometer. A silver coulometer is an example of gravimetric coulometer in which the amount of metal deposited at cathode or the amount of metal stripped from an anode is determined. We know that cations attract toward cathode and anions get settled at anode. So this principle is applied here. A silver coulometer is shown is the most satisfactory either in the cathodic deposition mode or better still in the anodic stripping mode in perchloric acid media. The increase in mass of the cathode gives the amount of silver deposited. From the mass of the silver deposited, the coulomb involved in the reaction can be calculated. So now we are reached to the applications. First, inorganic analysis. Determination of several metal ions, example Fe2 plus or iron, Ca2 plus or calcium ions, etc. To determine the purity of inorganic compound, to determine impurity of inorganic compound. These are some applications of it. Second, analysis of radioactive materials. The technique is widely adopted for the determination of uranium and plutonium and thus find extensive use in the nuclear field energy. We know that uranium and plutonium are the nuclear elements or they are radioactive elements. Third, microanalysis. This technique is especially useful for the determination of small amount of analyte with an accuracy of plus minus 0.5%. Fourth, electrolytic determination of organic compounds. Control potential coulometry offers a new step for the electrolytic determination of organic compounds. So I have explained my topic briefly. Thank you, friends.